All right, so we can do transformations on the tangent function just like we did for sine and cosine. So A, this number out in front, still adjusts the amplitude, but it's a little bit different than sine and cosine, and I'll show you that on Desmos in a minute. B is still adjusting our period, but for tangent, it is pi divided by B, or 180 divided by B. Okay, that is different from sine and cosine, because remember those were 2 pi and 360. C is still our phase shift or our horizontal shift, and that is going to move the whole things left or right. And then D is still our vertical shift, and that still moves things up or down. Now, again, we don't use the tangent graph nearly as often. It doesn't have as many applications as the sine and cosine. So we'll do a little bit of practice with the phase shift and vertical shift, but really not a ton. But let me show you what this looks like on Desmos. Okay, this is just your basic tangent graph that we've done. And the first thing I want to look at is changing the amplitude. So if we change that value of A, not like that, we're not, sorry. If we make A bigger, it just makes our seaweed steeper. And if you make A smaller, like 1/2, it kind of flattens it out there. I am not really particular about that, but I want you to kind of just get in your mind that a bigger A is going to make that really skinny seaweed, and then a fraction like 0.3 is going to kind of flatten it out at the bottom. If it's negative, that's going to reverse everything, and you'll have seaweed going down instead of seaweed going up. Now, the period, that's going to change how quickly we get through a cycle. So you can see we're getting more cycles or less. Okay, get those spread out. So that's kind of how that changes. These are sometimes hard for me to adjust. There we go. A vertical shift is just going to take everything left or right, as you can see. Fairly obvious. And then a vertical shift is just going to take the whole thing up or down. Okay. So those are what all of those transformations look like. And when we're doing these by hand, we're not going to get nearly that complicated. Okay. So let's take a look at this first one. How many do we have here? 3. Okay. So let's take a look at this first one. We're going to find all these key features. So the only thing that we have changed about this is the 1/2. That changes its amplitude. Okay, we did not change the center point, so it still goes through that 0, 0. We did not change the period, so it's still 180 degrees or pi. And asymptotes, we'll deal with those in a second. Okay, so we'll do this one in radians. It's good for us. Okay, so we have a center point at 0, 0, and our center points happen every pi. So at pi, we're going to have another one. And at negative pi, we're going to have another one. Now, in between those center points, we're going to have asymptotes. There's one here, and there's one here. So we have an asymptote at negative pi over 2 and at pi over 2, and they keep happening both directions. And then the only thing we've changed is it's a 1/2, so our seaweed is maybe a little bit flatter here at that middle part than it was before. And again, I am not really particular about that at this point. Okay, so that's what this one looks like. We'll take a look at these next 2 graphs in the last video.